Good afternoon. Today we will see the fourth unit, elasticity, creep, shrinkage and NDT test. So in last unit we seen about the fresh and hardened properties of concrete and what are all the tests to be done to assess those properties, and also we seen about that segregation and bleeding and the relation between compressive and tensile strength. Okay, so in this fourth unit, we will see about the non-destructive testing and also the engineering properties such as elasticity, creep, and shrinkage. Okay, so regarding the non-destructive testing, so generally what we will do means whenever we want to know a strength of any structural number, okay, at the starting of concrete, they may tell, okay, go for M20 grade of concrete. So when we are using the ratios for M20 grade of concrete for that beam number, we will additionally cast some cube specimens, and then it is almost around 6 or 3 based on the IS code, and then they will cure for 28 days and they will test in the compressor testing machine, and based on that value they will give approval for that whether that concrete has reached that strength or target strength of M20 grade or not. So this one we can know the starting state, but there is a question arises. Suppose if I want to know the strength of that same beam after 20 years, so there may be some heavy load will be acting, and due to the environmental condition and durability issues the strength may be reduced. So in that case, how to know the strength of that concrete used in that beam, or you don't have any records? I am going to do some renovation or for other purpose, I should know the structural detailing, what type of concrete is used or not. So in that case, what generally they will do means they will extract a core from that beam element, and then they will trim it the top and bottom, make it smooth, and then they will place in the compressor testing machine, and then they will find out its strength. But this is a part of destruction to the structural number, so this is called partially distracted. So in order to overcome this type of, you can see the mini picture of extracting a core from the column and other elements and trimming and testing in the lab like this. Okay, so these are all called partially destructive testing. So this type of test, what will happen means sometimes it will result in structural failure. Structural cracks will develop because we are creating a gap in a structural number. So in order to overcome these issues, okay, they have created some equipment and apparatus in such a way that without disturbing the structural concrete, we can find out its strength indirectly. Okay, so that will come under a topic called non-destructive testing. Here also you can see a column has been fully failed. Okay, so non-destructive testing means it is the process of inspecting, testing and evaluating materials, components or assembly. Materials means a cube, component means, okay, it is maybe a beam, column or slab, or assembly means it is a connection of beam, column and other things. So we can make a combination of that, and this one is mainly done without destroying the serviceability. That is what important. So as I told in the earlier state, okay, the serviceability is destroyed, but here without disturbing the serviceability of the part and system. Okay, so without damaging the structure, uh, indirectly we will find its strength. Okay, so what are all the purpose of NDT test? So mainly we can find the in place compressive strength, and second one we can monitor the rate of concrete strength gain. Suppose if you are making a concrete, okay, so at the first day what is the strength, at the third day what is the strength, at the seventh day what is the strength, at the 28th day what is the strength. So if I cast cubes for that, you can consider one, first day means 3 cubes at least, okay, third day means 3 cubes, for seventh day means 3 cubes, and 14th day means 3 cubes, and 28th day means 3 cubes. Okay, so almost 15 cubes you have to cast it to identify its strength at the different days. So instead of that, if we do this non-destructive testing, okay, without wasting the concrete in economical way, we will find out what is the strength gain. And next one, we can find out where the non-homogeneity looks. See, suppose if we make a concrete, okay, at the center of concrete, we might have some voids or some honeycombs in that. Okay, outside surface will be very good, but inside there may be some honeycomb in that. So that and all we can identify by using this non-destructive testing. And next one, we can make a relative strength. For example, I'm using the same concrete for this column, beam and slab. I can compare how much strength the slab has got, how much strength the beam has got, how much strength the column has got. And also I can find out the delamination. Delamination means crack parallel to the reinforcement or the surface of concrete. And what is the crack width, that also I can monitor by using this non-destructive testing. Okay. And next one, suppose if environment is there where the mechanical forces are more, consider this one is a jetty structure where continuously the sea waves will hit this structure. So how much it has been damaged, okay, to evolve in that one. And you consider this one is an industrial floor where acid has been spilled to that. So how much damages it has given to the concrete, those things we can identify by using this non-destructive testing. And next one, I can also locate the reinforcement. If I am not having a drawing of that building after 10 years, I want to locate the reinforcement, I can't able to break the surface or the cover concrete. Instead of that, there is a separate equipment is there called cover concrete where I can locate the reinforcement. And last one, the dimension of the structural number also. Suppose if it has been fully plastered, okay, what is the depth of the beam, okay, we can identify by using these methods. Okay. So next one, what are all the some of the NDT test and its application. So the first one is called surface hardness test. So here we can make use of this rebound hammer or Winchester testing pistol, okay, or impact hammer. By using this method we can indirectly find its strength of the concrete. And second one is penetration and pull out test. See, penetration means, okay, you may know about the gun. Okay, in a gun, if a bullet is shooted, what will happen, that bullet based on its force, okay, if the surface where it is hitting is very strong means, okay, the depth of penetration will be somewhat less. But if it is very weak, okay, means what will happen, that bullet will pierce into that surface and it will come out also. So based on the strength of the material, okay, you consider a concrete element or shooting with the gun. So if the bullet enters into that concrete, depth means what is the meaning? The concrete is weak. Suppose if the bullet is not at all entering, then what is the meaning? The concrete is strong. Okay, so based on the depth of penetration, here you can see a gun, okay, with this type of probes, it will be attached, and in the surface we have to place like this and we have to shoot it. Once shooting, what will happen, this probe will enter. Okay, if the concrete is weak, the depth of penetration will be more. Okay, if the concrete is odd, the depth of penetration will be less. So based on the depth of penetration we can indirectly identify strength. Okay, this one is called penetration test. And next one is pull out test. In pull out test, what we will do means, okay, we will make a drilling. Okay, if it is an existing concrete, we will make a drilling and we will, okay, attach a probe, okay, or a steel rod in that, and we will try to pull out that one. What force required to pull out that steel bar, that will indirectly we can identify its strength. And sometimes what we will do means, okay, while casting the concrete itself, we will place these probes. And at seventh day I want to know the strength means, at the seventh day if I pull out that steel bar, I can indirectly identify its strength. Normally it will form a cone fracture. Okay, based on that we can identify its indirect strength. Okay, so next one is dynamic or vibration test. So in this method, okay, we can find what is the nature of concrete inside, Okay, so the previous test and all only surface test. Okay, so in this method we are going to send some sound signals into the concrete. Okay, if the concrete is having more amount of voids or any air gap means the sound signal what I send will reach the other surface lately. For example, here you see this one is ultrasonic pulse velocity testing method. This is a concrete cube. Two transducers are placed. One transducer is called transmitting transducer, where the sound waves will be transmitted into the concrete and it will be received on the other end. Suppose if the concrete is having a big crack or a gap in that, what will happen? The sound waves will reach this receiver end slowly. Sometimes if a crack extend to the top to bottom means the sound waves won't pass at all. Or if the concrete is homogeneous mean the sound wave will pass fastly. So based on the time of reaching of the sound wave we can determine its velocity, and from that velocity we can determine the quality of concrete. Okay, so this one is a dynamic or vibration test. Next one, see sometimes we can go for this radioactive and nuclear methods also. So this and all in research level, but even though okay practically for some important structures like this nuclear thermal power plant other things we can go for this test. So this test we can find out is density and thickness. So like we are doing the x-ray for our body, we can locate the bones whether the crack is there or not. Like that for concrete also we can do this type of radiation passing test, and thereby we can locate the cracks in the concrete, how much moisture present, what is the cement content in that and all we can identify. And next one is magnetic and electrical method. I already told in the starting we can locate the reinforcement. As you know, reinforcement means it is made up of steel. So if you use magnet it will always attract to the steel. So based on this concept we can locate at what depth the reinforcement is there, the cover depth is can be determined. And by using the electrical method, always electricity will have an affinity towards the water. So wherever the water is there it will try to absorb that water. Okay, so in that way we can identify the moisture content and the thickness of the concrete. Okay, so what are the main advantage means we can access the hidden location. So here you see this picture, this one is in tunnel. Okay, I want to know the strength of the cover which has been protective cover which has been made. Okay, the thickness of the wall which has been provided. Okay, I can't take a core of that. Okay, and also I can't go to the top surface because it has been covered with the mountain. So for that I can use some okay rebound hammer test to identify strength. And also it is in better investigation. See, number of tests I can repeat it. Okay, so it is in better test. So normally if they will do two tests to confirm a result. One is this rebound hammer, another one is UPV, ultrasonic pulse velocity test, to determine a result. When compared to other methods, it is a better investigation. Why means at really okay in a structural number we are identifying a strength. Suppose if we cast a cube means the way of doing the curing will be different. How we will do curing? Okay, if you cast cubes along with the beam element means we will keep the cube okay. Yeah, inside the water immersion curing we will do, but actually the beam which is okay placed in the site, how it will be? Okay, we will be spraying the water only. Okay, once in okay 3 hours or 2 hours only we'll do the watering. So the strength actually in this site will be different when compared to the cubes for that particular beam placed inside the water. Okay, so in water curing, immersion curing, it will show more strength when compared to the site location. So only this type of NDT will give a better investigation and rapid accumulation of data. So n number of tests I can do, there is no restriction in that. Suppose if you make cubes along with the casted concrete means there is a restriction of 3 numbers or 6 numbers. Okay, so at any time if I want to know the strength means I can go for this NDT. And also it is less expensive. Okay, when compared to the destructive test, see destructive test means we have to purchase an UTM, okay, or this core driller. But nowadays this rebound hammer and all cost around some 40,000, which is less and also affordable, and we can get rapid accumulation of data in it. Okay, regarding the disadvantage, the main disadvantage, okay, we will see in the next class.